Hi everyone and welcome to our next tutorial. In the last tutorial we took a look at logic gates or Boolean logic, and now you understand what an OR gate is, what an AND gate is. I'm going to take a look at an application here of where we use gates and how they can be used, in this case, for simple encryption. So let's take a look at how we can do encryption. We're going to use something called an XOR gate, and the truth table is here. And just to show you how it works, we turn on the simulator. The XOR, and notice it looks like an OR gate, but it has this line in here, and that's how you differentiate an XOR from an OR gate. And its truth table is if one of these is on, similar to an OR gate, then the output will be on. But where they differ is they're both off, it's off, or it's a low. But if they're both on, it's actually a low, or digital zero. So it is different from an OR gate. It's similar, but the truth table is different. We can use XOR to do simple encryption, or what we call a cipher. We're going to do an XOR cipher or encryption. In other words, we're going to use the XOR gate to try to come up with an encryption that we could use to privately send a message to someone else. So the first thing we need to do is we need to set up 7 XOR gates. So I've got 7 XOR gates here. In your palette there is a place for an ASCII display, so I've set up an ASCII display here. And notice here that I have the top bit. This is bit 7. There's actually 8 bits here. It starts from 0 and it goes up to 7. I've got bit 7, and I'm always going to keep it low. I don't have an XOR gate here. So in other words, I'm going to do what we call a 7-bit encryption. So I'm going to count from 0 up to 6. I'm not going to worry about the 7th bit. And I'm just going to build a 7-bit encryption, and what it's going to be is 0000111. So this is what we call the encryption key, and if I'm going to secretly send you a message, I need to know what the encryption key is so I can use it to encrypt the message. You're going to need the encryption key so you can decipher my message that I'm going to send to you. So the first thing I'm going to do is I'm going to set up the encryption key. So for the 7 bits, starting with this one, remember this one's always just 0. So I'm going to count, I'm going to go to the least significant bit. It's 1, then 1, then 1. So I'm going to go down here. This is on, and then the rest of these, 1, 2, 3, 4, those are all going to be 0. So this is my encryption key. I can change it to whatever I want as long as I know what the encryption key is, and if I'm sending it to you, if you're going to decipher, you need to know the encryption key. So let's take a look at an example here, and I've got one here, and I'm going to encrypt the letter Q, and I'm going to see how it becomes the letter V. So first thing is I need to go look at the ASCII table, because I need to enter in the input letter in ASCII, and I'm going to do that in this column right here. So I'm going to go look for Q. So if I look at Q, I've got an ASCII table here. Capital Q is right here, and the decimal value is 81. So if I go back to my program, what I'm going to do is I'm going to put in 81 decimal into binary. So 81 would be, well, I need 64. 64 plus 32 would be too much. I need 16. So those two together add together to give me 80. And I'm going to need one more. So I need that one. So Here is my input letter in ASCII. Its value is decimal 81. In binary, it would be this value right here. Now what I'm going to do is that's going to be sent through each one of these XOR gates along with the encryption key. So we're doing an XOR encryption or an XOR cipher using this encryption key on the letter Q. In order to activate the ASCII table here, I just need to turn this on, and what pops up is the letter V. So the message you're going to get is going to be a V. Now, if you get a V, how are you going to know I'm really trying to send you a Q? Well, what you're going to do is I'm going to reset this ASCII display, and it came out to a V. So if I go back into the ASCII table, and now if I look for a V, here it is here. Capital V is actually in the ASCII table in 86. So if I go back in, and now if I put in 86, so I need 64, I need 16, that much is 80. I need a 2, a 4, and a 2. I'm going to turn this one off. So that gives me a value of 64 plus 16 plus 4 plus 6 is 86. And if I decipher it back through my cipher system, it should take me back to my original letter so someone can decipher it. So if I turn it on, sure enough, it turns it back to a Q. So let's try this again. I'm just going to reset, and I'm going to keep my same encryption key. I'm going to put all these back. We're going to try a different letter. So if I go in to the ASCII table, I'm going to pick a different letter. Let's say capital F. Capital F is 70 decimal. So if I go in and take a look at 70, so I'm going to need 64 plus another 6 would get me up to 70. So I need this one and I need this one. So there. That's my input letter. Decimal 70, just going back to check, decimal 70 is an F. But when I cipher it through my XOR encryption using this encryption key, that comes out to capital A. So I enter it in, going back to here, I entered in an F, and it actually came out to be an A. So now if I go back and take an A, I should be able to convert it back to my letter that I tried to encrypt, which was an F. So if I go back to my table, 70 was F. If I go back to A, it's 65. So now if I go back to here, and if I put in 65, so I need a 64, I need to turn this down, and I need this on. That gives me 65. I should convert my A back to an F. So if I try it, there, I converted it back. So that is a simple way to do encryption. This was my encryption key. It was a 7-bit encryption. In order for you to read this message, I need to give you this key, and you need to set up the exact same XOR system. That's it for this tutorial. Take care. We'll talk to you soon.